it's a really good introduction actually to what I was going to talk about, because it turns out that I actually started my life well, as a university professor in Australia, actually at Curtin University. And during that time I was actually also program director for the DCR2 logging and sensing for a short period of time, about a year and a half. And part of the problem we had was that when we actually asked people why don't they acquire petrophysical data, they said, well, between putting another hole in the ground or doing logging, we'd rather put another hole in the ground. And so we said, okay, well, what we'll do is we'll make something so that you don't actually even see that we're collecting data, but once we have the data, we'll be able to do something with it. And so if you come and see me, because I'm with Universite Laval now, but I still represent the DCRC in Canada once in a while, I'll talk to you about the autonomous song that we've developed over there, and that's being commercialized by Fort Lanier. But what I've done though is, and so one of my pet things to do is actually petrophysics, and I do wireline logging and develop tools for wireline logging. So, but for today, I've actually was a good student and I read the papers, so I actually followed what Ken had asked me to do. And so I came up with, fortunately we have the answer, because the answer is 42. Yeah. It's okay. So now we just have to figure out the question and we'll be right? One of the papers that I read was complaining,
the green one,
okay, was complaining that students now don't know anything. Okay, basically they don't know how to run a plant. The example that was given is a metallurgy kind of example. I like the quote from Einstein that says that education is not the learning of facts, but the training of the mind to think. And so, between you and I, that paper was written by somebody that seems to be frustrated to be at the end of the career and not realizing that he has the perspective of somebody that's been doing this for 4 years. And so it would be quite disappointing if my graduate, after 4 years of a bachelor's, knew as much as the guy that's been working in this for 4 years. And so the thing is that you have to actually be willing to spend the time to actually bring people up to speed. And so I think I'm also part of this interval where there's supposed to be no one. So we're probably the mammals. Okay, the dinosaurs are dead and we're gonna run over the earth eventually. It's just we just have to hide in the shadows for a while. But the thing is that generally we get from training what we put into it. And so when we actually hire students for the summer and we basically send them to the core shack and we say, well, here are the 3 different types of rocks you'll find this year, and then go and log the core, then we get things that are a little bit variable. It's actually James Cleverly that showed me once a core that had been completely misdiagnosed by the company. So they had spent all this money drilling over a 1,000-meter hole, and then they ran out of money, so they sent the summer student to log the core, and then they got what they got. So they had a really nice deep hole, but the information from it was less than reliable. So we have to actually make sure that we're willing to spend that time to actually train our people. Based on that, we've heard this morning also that, you know, universities were a little bit behind in terms of being able to catch up with the realities of an industry. It's mostly based on our funding model. And like I said, I was in Australia, I'm now in Canada. In Australia, I was working with research groups that had millions of dollars. I have my answer. My answer is really nice. It's $30,000 a year. What can you do with $30,000 a year? You can hire a PhD student and maybe you go to a conference or 2 a year or something like that, but that's pretty much it. Okay? What is $30,000 for you guys in industry? It's not necessarily that much, right? It's a short hole, yeah. And so, to be able to actually play in the same game as you guys, we need to be able to actually make investments. But right now, doing science for science sake is difficult. With the funding that we get as young researchers, one of the complaints of this guy also was a metallurgist. He said, well, we don't spend enough time on machines. fine. The reason why we do stuff on computers is, yeah, it's cheaper. It's also a good way of not blowing up the entire department if something goes wrong, if you're playing with nasty chemicals. But in general, we do it because it's cheaper, and usually students are supposed to get something out of it. If it's important to industry for us to use machines that they will see in the future, money has to come from somewhere to be able to invest in those machines. Or we have to actually be able to send students so that they can learn on those machines. But generally speaking, we won't necessarily have a metallurgic plant in the basement of the PDAC where I work. It's not really looking for it. All right, so that's my soapbox for that. Now, errors using inadequate data are much less than those using no data at all. And that comes back a little bit, so I'll fly in the face of the comment earlier that it was like garbage data. Yes, there's data that's unreliable. There's data that can't be used for very much. But as long as you treat it that way in your model, then maybe it's not so bad. You just don't put a lot of weight to it. Even if it's a one or a zero kind of thing, maybe it has value. At least you know that that data point has been sampled. Okay? Just throwing it away means that you'll probably just end up trying to collect it again at some point. Theories crumble, but good observations never fade. Okay, that goes with the same sort of mentality, which is that we were just talking about petrophysics. Okay, so you can do petrophysics on core. It's relatively expensive because you have to actually recover the core first, and then if you have a petrophysics lab, then you have to ship the core over there and then measure it. The technology is there. You've got things like core scans, right? So you can do your density, you can do your resistivity logging, you can do your density logging, all in a semi-automatic way. It's relatively slow, but it gives good results. You also have wireline logging. The thing with wireline is that often we haven't actually paid enough attention to the dynamic range of our tools. And so sometimes we just conclude, it doesn't work here. It doesn't work for a reason. So if you use an induction tool in an environment where it's highly resistive, you don't get signal. So whatever you get is relatively noise. Same way if you actually use the same induction tool, but in something that's way too conductive, you just get negative numbers. And then people ask you, what are these negative numbers? You have to say, well, this is the tool saturated. So often, people that have tried to be good students and be healthy and eat their carrots, which is this petrophysics, they see that they don't get the results they expect because basically the tools don't perform as they expect in different environments. So there's a little bit of work that needs to be done there. So since I thought that I might have some geologists, I've been accused before of being a geophysicist and not actually showing rock core or actually being too close with my rocks. I've actually put well, it's not core really, right? So it's a vibrosonic coring of a waste pile in Thetford mines that used to be used for asbestos. And so most of you will probably wonder, well, that seems to be a frivolous activity to go and core this 130 meters worth of waste. If you gave this to a geologist, he would say, well, it looks pretty much all the same thing. There's variations probably in the grain size, but mostly it's gone through the mill, it's been crushed, and then it's been put in a pile. So if this is all you got from that hole, it'd be a little bit disappointing. The reason why we did it is because there's actually a natural process that's CO2 sequestration through carbonation. And so the magnesium-rich minerals actually react with the CO2 and the water and become the carbonate. We, from that start, decided to actually have a petrophysical model for that reaction. And we said, well, okay, what will the carbonate do? Well, it'll coat the grains. So if it coats the grains, it means that our resistivity will go up. And looking at literature, we also noticed that the susceptibility, the magnetic susceptibility goes down. And so we have all this fancy analytical equipment to actually check for carbonates. But the question is, where do you check? We can't take everything on the sample. So we just did our logs. So we'd expect where we have high resistivity and low magnetic subtlety is where we get our carbonates. And so in this case, the peaks that you see in red, basically when we actually did our analysis, we actually saw that there was higher carbonates. So it's one of those things where we've actually done the investment of doing the whole, doing a little bit of petrophysics, and it actually makes a lot of sense because we actually find the information that we're looking at. This is actually an example that's just been published from some colleagues also at the NRS in the leading edge. And this is, gold is notoriously hard to find because gold is where gold is, right? But what they've done here is actually looked at 13 boreholes as training data sets for Hudbay. And through their methods, they've actually discovered that when you look at the density and you look at the other about 8 logs that you have there, you get quite a high prediction of where your gold mineralization is. And so again, if you've done your investment of your hole, collecting petrophysical data makes a lot of sense. Your training data set originally takes a little bit of time to do, but then after that it goes actually a lot faster than having to assay every meter. It can actually basically tell your geologist, maybe you should look at that piece of core again. Maybe you've missed something. So it's a way to go quite rapidly through information that you already have and find good results. So that's it for now. Thank you.